This video will cover section 2.4, and this section is on linear functions. So all of these functions should form straight lines when they are graphed. Alright, so when you look at a linear function in its basic form is f of x equals ax plus b. Alright, notice here's my x variable. The a and the b are numbers. In MyMathLab, it's going to ask you to write it in standard form. Standard form is ax plus by equals c. So we'll look at a couple and note how to write it in standard form when we get a little bit further. Alright, so there are a couple of different ways to graph linear functions. One such way is the way we did it a couple sections ago, where we pick values for x and solve for y, or we pick values for y and solve for x, and we got a set of ordered pairs. Another way that you can graph linear functions or other functions is to use what's called the x and the y intercepts. Now the x-intercept is where the graph crosses the x-axis. So whatever that point is, where the line crosses the x-axis, alright, the coordinate where it crosses is going to be whatever value x is, and then since it's on the x-axis, the y is always 0. Alright, for the y-intercept, that's where the graph crosses the y-axis. And so this point where it crosses the y-axis is going to have some value for y wherever it's crossing the y-axis at, and then the x value is going to be 0, right, because it's on the y-axis. So using that information, we can graph our equations. So here, let's look at the first equation. It says f of x equals negative 2x plus 6. Alright, so if I want to graph using the x and y intercepts, what I'm going to do is first let x be 0. So I'm going to say f of x equals negative 2 times 0 plus 6. And so what that tells me is when x is a 0, the y value is, let's see, that would be 0 plus 6 is 6. So that gives me the coordinate 0, 6. Alright, so that's going to be the first point I graph. So I'm not going to go left or right any. Alright, and this is going to be the y-intercept. I'm not sure if I said that correctly to begin with. This is the y-intercept. We let x be 0 and solve for y. Alright, so I'm at 0. I'm not going to go any left or right, but I'm going to go up 6 and put a dot. Alright, next I'm going to find the y-intercept. So if I'm looking for the y-intercept, I know that on the y-intercept, on the x-intercept, the y has a value of 0. So I'm going to come over here, and in place of y, which we know already, that's the same thing as f of x. So we're going to say 0 equals negative 2x plus 6. And then we're going to subtract 6 from both sides. We'll have negative 6 equals negative 2x, divide by negative 2, and we find that x is a value of 3. So that gives us the point 3, 0, which is the x-intercept. So starting here at the origin, I'm going to go right 3, and I'm not going to go up or down any, because my y is 0. Alright, with these 2 points, now I can connect them. Alright, and now my line has been graphed. When you're in MyMathLab, it's not going to require you a certain, not always, sometimes it will, let me say never, not never, sometimes it will require you to graph a certain way. So if it doesn't specify x and y intercepts or pick points and make a chart, you can use whatever method you like to graph your equation. So when I worked through the homework problems, what I did was I used x and y intercepts. To me, it's a lot faster. Alright, looking at the next equation, it says f of x equals negative 3. Alright, this type of equation we refer to as a constant type of equation because there is no x variable. And what it means is that no matter what I pick for x, the y value is always going to be negative 3. So I can't really do x and y intercepts on this one because there's no x to fill in, and it just says y equals -3, and so I could pick any value I want for x, and y is going to be 3. So the easiest way to graph these is just to go where y is -3. So that'd be from the origin down 3, 1, 2, 3. Alright, and then it doesn't matter what x value you pick, y is going to be 3. So that gives us what's called a horizontal line. Alright, so you may encounter that at some time later. Horizontal lines come from when f of x equals a constant, or we could say y equals a constant. But it doesn't matter. Look, if x was 1, y would be -3. If x was 2, y would be -3. If x was -10, the y would be -3. Alright, those are the easiest to graph. Alright, looking at the next one, this one says x equals -3. Alright, and so that means it doesn't matter what value I pick for y, x is always going to be a -3. So if I went through and picked coordinates, x would be -3, and I could pick anything I wanted to for y. I could pick 0, -3, -1, -3, 5. It doesn't matter. Alright, so if I go to where alright, so we want to graph this equation. We're going to go to where x is a -3. So from the origin, I'm going to go left 3, and then I can go put a dot here. I can go up 1, I can go up 2, I can go up 3. It doesn't matter what what y value I use. Alright, and this type of equation results in a vertical line. Alright, so note the difference between what gives you a horizontal line, that would be f of x equals a constant. Alright, and note what gives you a vertical line, and that would be x equals a constant. Alright, looking at the next equation here. Alright, so for this one, if I fill in, using x and y intercepts, if I fill in a 0 in place of x and y, what I'm going to end up getting is the same point. So if I filled in, let me just demonstrate that to you. If I filled in a 0 for x, I would end up with -5y equals 0, y equals 0. That would give me the point 0, 0. Then if I do the same thing and I fill in a 0 for y, I end up with 4x equals 0, which results in 0, 0. You have to have at least 2 points to graph a line. Alright, so I can graph this right here, 0, 0, is still a point on my line. Alright, but notice it is the x and the y intercept. They're the same. Alright, so that means I have to find some other point. It doesn't matter what it is. So you may want to solve this equation for y, or let's see. If I solve it for y, I'll have -5y equals -4x. I divide by -5, I get y equals 4/5 x. So it looks to me like the easiest value to pick would be a 5. So when I fill in a 5 for x, I'll have 5 times 4 is 20, divided by 5 leaves me a 4. So then I can go right 5 and up 4. Alright, then connect the dots. Alright, and so there my equation is graphed. Notice I used a combination of x and y intercept and randomly picking a point. Alright, like we did on the other. You may be asked to find domain and range. Remember, on any on the linear equations, other than the constant ones, the domain is going to be -infinity to +infinity, and the range is also going to be -infinity to +infinity. Alright, so anytime it's a linear equation other than the constants, alright, that should be your answer for domain and range. If it's the constants, alright, notice that your domain for this one, the f of x equals a constant. The domain is all of the x values. So the domain would be negative infinity to positive infinity. However, there's only one value for y, the range, and that would be a 3. Alright. On this one, the domain would be just one value, that negative 3, but the range goes from one end to the other of the y-axis, so it would be negative infinity to positive infinity. Alright, let's take a minute to look at slope. Alright, you've probably all heard of slope. It's defined in a couple different ways. But anytime you see the letter M in an equation, alright, it's referring to the slope. Alright, slope can be found a couple different ways. One such way is the slope formula, where you take the y values and subtract them over the difference in the x values. And that's exactly what this right here is saying. That delta, that triangle means delta. That means the change in y over the change in x. And you've probably also heard it called rise over run. So rise, if you're rising, you're thinking about going up, which means you also have to come down. So up and down is the rise, and then the run is your left and right movement. All right. When we think about vertical and horizontal lines, like we talked about just above, all right, the slope of a vertical line is always undefined. So anytime you see x equals some number, we know that's a vertical line, and we can say automatically its slope is undefined. And anytime you see y equals or f of x equals a number, we automatically know now that's a horizontal line, and its slope is going to be 0. Alright, so what we're going to do is just take a look at finding the slope given some points. So these points here are some points on some line. I don't know what the line is. It doesn't matter at this time. They're solutions to some equation. They're on some line. Alright, and so what we want to do is find the slope of that line, its rise over its run. Alright, if you're given 2 points, the way you can find the slope is to use the slope formula. Alright, and it is y2 minus y1 over x2 minus x1. And just like the other, when we talked about x2, x1, y2, y1, it doesn't matter which point you label x2, y2, or x1, y1, okay, as long as you keep the 2's and the 1's together. Alright, so you may call this one x1 and this one y1, x2, y2. Alright, so if I'm looking for the slope, I'm going to say y2, which is negative 3. The formula tells me to use subtraction, and it's then subtract y1 over, it tells me to use x2 minus x1. Alright, so notice I used a minus. That's what my formula tells me to use, and then my x1 is a negative number. Alright, so I have to say minus a negative. Don't let that get you. Alright, then we have negative 3 minus 8 is a negative 11, and then minus a negative becomes plus, so that would be 2 plus 4, which is 6. So we can say the slope of this line is negative 11 over 6. Alright, looking at the next one. Alright, I may call this one x2, y2, x1, y1. Doesn't matter which one gets the x2, x1. Alright, to find my slope, I'm going to say y2, which in this case gives me 7, minus y sub 1, which is negative 4, over x2, which is 2, minus x1, which is also 2. Alright, 7 minus negative 4 becomes 7 plus 4, which is 11. And then 2 minus 2 is 0. Alright, and we all know that anytime 0 is in the denominator, that can't be. So we would say this slope is undefined.